In this lecture, we are going to see that it is possible to specialize a single method from a full class template. In the last lecture, we saw that we had the ability to specialize an entire class template, and this was a completely separate class in which we had to explicitly put in all the other methods available in the class template for this to behave completely like our class template. But in this lecture, we are going to see that it is actually possible to specialize a single method from a full class template. We will be using our box container class template as we see here. And to set up a simple example, we will design a getMax method, which is going to return the maximum from our box container class. For example, if we are storing an integer, this function could return the maximum integer we have in our collection. And it is going to do the usual thing to compute the maximum. It is going to be looping around, keeping track of the index where we have the maximum element. At the end of the loop, we will have the maximum element index stored in max index here, and we can return it to be used by whoever called this function here. So we have this method n. Let's head over to the main CPP file and try to use it. So we can create a box container of int. As we do here, we can add a bunch of things inside. And after we have data n, we can print out the collection. We're going to see the data n, but we can call the max member function and get the maximum to be printed out from our box container here. In this case, I think 62 is going to be our maximum, so we can see it printed out. But if you use this class with the const_car pointer argument as our type here, this is not going to do what you want, because remember, in our body, we will be comparing what we are storing in here, and if our box container is storing const_car pointers, we will be comparing pointers if we do something like this. So we may get erroneous results, and this won't be comparing actual string data. It will be comparing the pointers that point to string data, and this is mostly not going to do what we want. To solve this problem, we can opt to specialize this method for const_car pointer. And the syntax to do that is really simple. Now that we have seen how we can specialize an entire class, we put in our template declaration, which is going to be empty. We won't have anything n. Here we are inlining this to make it usable from a header file. But if you want, you can put the implementation in a CPP file to avoid ODR issues. This is going to return a const_car pointer, and it is going to be taking nothing n. It is a specialization for const_car pointer in our class template, and it will loop around and use the strcmp function to compare strings. So we will be taking the string at the current index and compare that with the current maximum we have, and whatever is the maximum is going to be stored in our max index, and this will be used in the next iteration to see if we don't have anything that is greater than the current maximum string. At the end of the loop, we will return our maximum string, and whoever called this function will have the ability to use this. But the main message here is that we are specializing a single method in an entire class template. This specialization is not going to be a template. It is going to be a real C++ code. So if this definition shows up in a header file, we will get ODR issues. If the header is included in multiple files, we need to be aware of this. But other than that, this is going to work just fine. If we use the code now to store in const_car pointers, we will see that we will get the correct maximum printed out, regardless of the pointer addresses where these things are stored. And this is going to work really well. Now that we know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is Tempate Specialization with select member functions. We are going to grab our template files and put them in place. We can do that. We are going to grab our box container class, the files for that, and we're going to put those in. We have a header and a CPP file, and you can grab these files from the resource section of the course and use them however you see fit. This is going to save us a few seconds because we don't have to set this up. So let's open this up in Visual Studio Code and this will give us our class template, which we already know. We have two template parameters in, but this is not going to matter that much. So let's see how we can use this thing. We are going to go down and see that we have a method to get the maximum. This is going to be looping around trying to find the maximum in our collection. For example, if it is storing integer types, we will grab the maximum integer and return it from this function here. And this is going to work just fine. So let's head over to the main CPP file and try to use this. We are going to include our box container class. We're going to do that. And we can take out all the garbage we have here that we don't need anymore. We can put in the code to play with this for integers. So we will add the data. And if we print the data, we're going to see it printed out. And here we are using our getMax method. Again, this is living in our header file. And you can see the definition for that right here. It is going to be looping around, looking for the maximum, and we will return our maximum to be printed out in the main CPP file at line 18 here. We can try to build this program and see it working. Let's pass this through GCC, our compiler. The build is going to be good, so we can bring up a PowerShell window and try to run this. And if we do this, we're going to be able to print these guys. You see, we print from 10 all the way to 8, the last element, and the maximum is going to be 62. If we change, for example, and change the guy here to be 330 and build again, this should be picked up as our maximum, and we should see it printed out. Let's make sure we see that. If we run Rooster, we're going to see that our maximum is now 330 and our program is working as expected. But if we try to use const_char pointer template arguments, this is going to not work as we expect. Let's put a simple separator in to really drive this home. So let's do this. And we are going to create a box container of const_char pointers as we see on line 22 here. This is going to set this up and we can add data. Data is const_char pointer literals. That's what we get here. And we put in apple, kiwi, and banana, and we want to print the maximum between these guys. Now, let's make sure we don't have our specialization in, because I think I had put this in earlier in the code that I have included here. Let's go all the way to the end and we're going to see that we have a declaration of our specialization. Let's remove this. We don't need this. And we are going to run the code we have in the main function here. Let's make sure we pass this through our compiler. The build is going to be good because we will have these guys in, but looks like we have a linker error and it is not finding getMax const here. Let's make sure we pass this through GCC. We're going to do that and we are going to see that we have an error here. What is happening here? If we look at the message from the error, we are going to see that we have multiple definitions for the getMax function. And let's go to the container CPP file and see that I don't have a definition. And this is the offending code. We have a definition here, and the compiler is also going to generate another template instance for the data that we passed in here, and they are going to be exactly the same. That's why we have a multiple definition here. So let's make sure we have no specialization in here. Let's comment this out and build again. Hopefully this is going to get rid of the problem. We're going to pass this through our compiler. Now the build is going to be good. We're going to see what we get if we run the program. Let's run Rooster. We're going to see that the maximum is banana, even if we really see that kiwi should be the greater thing because it comes later in the alphabet. This is what we would want. So this is a problem, and we are getting this problem because in our current implementation of getMax, we are comparing whatever we store in our container directly. So here we are really comparing pointer to characters, and comparing pointers is not going to give us the result we expect by comparing string data. So we need to specialize the getMax method here to work with const_char strings, and we will have to use the facilities from the C-string header to compare strings correctly, and that's going to work well. So to solve this problem, we can go all the way to the end and specialize the getMax method. Let's go there and show you that we can do this. I have it in, so I am just going to uncomment it. And this is going to be an inline implementation to get rid of ODR issues. You can do things like this. And this is going to be comparing const car pointers. So this is good. This is our specialization for the getMax method. And we will grab the index where we store the maximum element. We're going to be looping around, but notice that our comparison is no longer using the direct logical comparison operators on the data that we have in our container. We will be comparing using the strcmp method. If you want, you can check this out at CPP reference. You're going to see how it works. We are going to give it two const car pointer strengths, and it is going to compare them. If the left one is greater, we are going to get something greater than 0. If the one to the right is greater, we are going to get something less than 0. And if they are equal, we are going to get a 0 out of this. That's what we use here to decide if one is greater than the other. So for whichever is greater, we are going to be storing its index in max index here. And when the loop is done, we will have the index for the maximum strength stored in our max index variable here. And we can return whatever const car pointer strength is at that index, like we do at this line here. And this is going to be available to whoever might have called this function here. Now, if we have this specialization n, it is going to be prioritized by the compiler if we call the method on a container of const car, because the compiler is going to know that this is going to work better because we know better how we compare const car pointers because we put in this thing here. Hopefully this is making some sense. Let's build and see that the problem actually goes away. The build is going to be good as you see here, so we can clear and run rooster. And this is going to tell us that the maximum now is kiwi, and this is what we expect. Let's try and put in something else. We're going to add something that is greater than anything here. So we're going to say car pointer box. Is it what it's called? Yes. So let's say ptr box and add, and we are going to say Zeus. Let's do something like this, and we expect to get this guy as our maximum. So let's build again and see what we get. The build is going to be good, so we can clear and run rooster, and this is going to give us exactly what we expect. Our maximum is going to be Zeus, and our template specialization is being picked up by the compiler and used. If you don't want to inline this, you also have the option to put the implementation in the CPP file, so we can comment this out. Make sure we only have in a declaration for our specialization. We can do something like this and put the implementation in our CPP file. So we can do something like this and put this, for example, in box container CPP, and this is going to be picked up by the compiler, and it is going to avoid the ODR issues we might run into if this is showing up in a header file, because mind your steps, this is real C++ code. It is not a class template. So having this in a header is going to be a recipe for disaster. By now you should know this. Let's build and show you that the problem actually went away with this setup. The build is going to be good. We can clear and run rooster, and this is going to do exactly what we want. This is really all I had to share in this lecture, showing you that it is possible to specialize a single method from your class template. This is going to save us from having to re-implement everything as we did in the last lecture when we had a full class specialized for a given type. And we will still have the ability to reuse whatever we worked hard to set up in our class template here. So this is what I recommend. Don't specialize a full class template unless you have a really good reason to do so. We are going to stop here in this lecture. In the next one, we will start and learn about how we can set up friendship relationships to class templates. Go ahead and finish up here and meet me there.